In number 62, we're doing a definite integral. So just remember that the answer to a definite integral is some number, right? It's the value for the area under this curve, or the area between the curve and the x-axis. So I've rewritten the problem here in blue, and the only thing I want to point out is that I changed the limits of integration from negative 1 over the square root of 2 to positive 1 over the square root of 2 to negative square root of 2 over 2 to positive square root of 2 over 2. They are the same. I just like to write this version of that value because that's usually how students remember it in the unit circle. Okay, so the key to this problem is the fact that we have this formula for derivatives of inverse trig functions. And I think you'll find if you look at your chart that the derivative of the inverse sine of x is 1 over 1 minus square root of 1 minus x squared. And that's essentially what we have here, except they changed the letter x to letter p. So when I do a problem like this, I know that 6 is there, so I'm going to talk about that in a minute. But when I do a problem like this, go ahead and just start by factoring out that constant multiple. In this case, it's a 6. And then you'll see that the problem looks exactly like this derivative formula. This is negative square root of 2 over 2. This is the square root of 2 over 2. And now I have 1 over a square root of 1 minus p squared dp. And remember, when we're doing a definite integral, we need to find that antiderivative. So in other words, we're just going to go backwards from this derivative formula. So the antiderivative here must be inverse sine of p instead of inverse sine of x because of that formula. And then don't forget, we've got this 6 here, so I'm just going to bring that down. It's a constant multiple. You just multiply it on. And remember, this is a definite integral, so we have to evaluate this antiderivative between these two values, negative square root of 2 over 2 and positive square root of 2 over 2. And so what that looks like, let me get some blue here, is I'm going to do 6 inverse sine of positive square root of 2 over 2 minus 6 inverse sine of negative square root of 2 over 2. These inverse trig functions each return an angle, so it's going to be some value off the unit circle. The angle that gives you a sine of square root of 2 over 2, that's pi over 4. So this is just 6 times pi over 4. And then the angle that gives you a negative square root of 2 over 2 in the domain for the inverse sine function is, that's negative pi over 4. And we're going to multiply, negative pi over 4, we're going to multiply that by 6. Sorry. Okay, so negative pi over 4, we're going to multiply that by 6. And then I'm running out of space here, but let's just write what that equals. So this is, no, I don't want you to solve it. I can do it myself. This is 3 pi over 2 plus, because the negative times negative is a positive, plus 3 pi over 2, which is 6 pi over 2, or just 3 pi. Oops, the computer's wanting me to, or it wants to solve it for me because it's got that Apple Intelligence stuff going on, but I like to do the math myself. So let's see if we've got this thing. We had the definite integral. We made use of this formula for the derivative of inverse sine of x. We did the antiderivative and evaluated it between the limits of integration. And then we just plugged in the top number first, then the bottom number, and subtracted them. That's the fundamental theorem of calculus, and you end up with the 3 pi down here in the corner. So that's how that problem works. If this doesn't make sense, let me know. In the meantime, take care.